All right, let's get back to working on debug draw. So we had some issues. We definitely had some issues. Ah, yes. So I have a problem here that I freeze the arena only on the init and not before each or at the start of each frame. So I think that should be not that difficult to do, but I guess I'll have to expand my memory arena API. So what I would like to do is let me see. So what I do for unfreeze, maybe I can just do freeze, and then alternative to that I do memory arena pop, or I don't know, how do I call this, thaw? No. Reset to freeze. Does that make any sense? Revert to frozen. Revert. Okay, maybe revert. Although that kind of sounds like reverting the last push. Yeah, whatever. Let's just call it revert. And I basically want to do all of this. Keep pressing shit. All of this, except of course for all of this stuff. So yeah, maybe do that, but don't reset frozen stuff. Right, and don't reduce the freeze count because we're still basically frozen. And then in debug draw.cpp, I want to use that. I feel like there was another problem I realized. Maybe that was it. Don't know. So first of all, this is some weird stuff. To be honest, I don't know what those dots are. I actually don't know what the hell that is. Something is really, really wrong. Let's see, did I mess anything up here? Not particularly. Let's just double check. Oh. Maybe I did mess up something more significantly. Let's say I don't, oops. Let's say I don't do that. Okay. Just in case, let's get rid of this too. And let me even get rid of this. Let me check my git log. I think I found the culprit. Basically, when I'm doing GL draw elements, I'm using this draw mode, but this draw mode is not actually initialized anywhere. So let me look at sav init GL defaults, and let me add a thing here. We'll do GL state draw mode, and this is GL enum, right? So this should just be GL triangles. Okay. So now back to here. Let's do all this. Okay, so now I crash. So what I do again? On left click, I draw point. All right. Let's see. So my verts added is not equal to vert count. Vert count is 1. My point is null because my points is null. Oh. Okay, I did something really dumb here. All right, so here is the source of the stupidity. So point next will be whatever is on the top of the list, and then the top of the list is going to point to the point itself, and the same goes for line. Take a look. All right, what now? So we're doing draw points. We're adding our point. Right, so we only got one. No, okay, we're still doing something really bad. It's pointing to itself. Okay, did I still mess something up? Point next to that, and that to that. We push struct on the arena for the point. Ah, right. So that's what yeah, this is the thing that I thought of and then forgot again. So the problem is that I don't just need to revert the arena, but I also need to reset the state, right? So that means, because even though we actually, oh, and we don't zero. So even though that memory is invalid, all the stuff is still there, and we keep like cycling, something like that. Basically, the point is all of this stuff needs to go too. Let me see, maybe a little macro. I'll have to do this. Boom, boom. Right, all of this should be, this stuff should be nulls. This stuff should be zeros, which of course is the same thing. So we basically reset this every time. All right. So now it's hard to tell if it's actually drawing something. I think I also need to set my point size at the very least, if nothing else is wrong. Let me double check how to do that. All right, so let's add functions to set that stuff. Set point size at 32 size, and then just call GL point size and then set line width GL line width. Copy that. All right. So I guess let's just do set point size here. Let's say 10 right now, and then we can set it back to 1 here. And then let's do the same for lines. Set line width. Set line width 1.0f. F. All right. Okay, still nothing. Oh. Ah, right. I forgot that I didn't actually. Oh no, I did. I just didn't. I just didn't scale it or something. What did I do? Ah, okay. Yeah, I wasn't supposed to do this. It's already in world pixels. Which I guess let's do that. There we go. All right, so that's a point, and then we could also do multiple points. Let's do target plus equal to v2. This is in pixels, so let's do like 1 tile size. Let's just add a bunch of points like that. Hey. Kind of nice. And also Draw a line from start to end in green. It's insane how thoroughly I'm testing this. Just like, wow. Looks good to me. So maybe let's also do this. So let's say that's the end. Start will be game state entity store dot controlled entity p. I really need like a component wise multiplication for vectors. I guess I can do that and then say start.x multiply by, this is test code, come on. My width and height is equal. There's no point. Okay. So I can do that. And yeah, I think that's about right. So there we go. Oh. Oh, that's okay. That's okay. That's just on that clicking. Okay, so this is pretty much what I wanted. Yes, obviously this is just debug, because if I wanted this to be something presentable in the game, besides of course these like points and lines being ugly by themselves and not having like nice kind of, you know, like a little transparent boundary to it and stuff like that, and the, you know, kind of continuous curve. But also the biggest thing is that we're not scaling it down, right? So like this is huge compared to the world, which, you know, we wouldn't actually want it to scale down exactly to the world size, or like to the, you know, to the appropriate scale of the camera, because the line would just be invisible then probably, but like we still want to probably scale it down somewhat. I don't know, whatever. But yeah, I think that works for me. So I think we can end the debug draw stuff for now and start working on actually analyzing some map data to be able to do lighting, and I'll get into that in a second. All right, so for lighting, what I would like to do is maybe I can bring up Milton and take a look at this. So basically I want to block off chunks that are like outside or that are behind something that is blocking the vision from the standpoint of your position. And the way I want to do this is like is basically by doing a pre-processing step on our tile map, and extracting basically a list of edges and then projecting those edges onto kind of the boundaries of the level, and then filling out those quads that get generated with black. At least for now, that's how I want to do this, just to kind of get started. What to do later, I'm not sure. There are a few problems already because, for example, because it's a kind of ASCII game, there is no substance to the edge itself, right? It's just the beginning of a tile. The actual in-world object is the tile itself, so I have to show at least one tile. Whereas this will just cover everything outside of the line of sight, and you would only see the room, like you would just not see any of this. And obviously we want to show at least a boundary of tiles for every room. So yeah, what I want to do now is a pre-processing step to just go through all these tiles and generate a list of edges so that eventually we can kind of describe this map as like vertices and edges between, I guess not between, but like of enclosed shapes or open shapes. I guess it wouldn't matter. Like the way it would work is that if I'm inside the wall somehow, then I would actually, you know, look the other way and have my line of sight kind of be blocked by open spaces, right? So yeah, I think that's okay. I just want to see what that's going to look like, honestly, and see if, you know, performance of that is manageable. I mean, it should be. And then we can add all these complexities of, you know, all the stuff that I mentioned, basically. So yeah. Okay, so I think it should be part of my level, at least for now. I just want to store I guess I don't know, should I call it like a mesh or something? Sure, level mesh. And in here, I want to have a list of vertices and a list of edges. I guess let's just go like all in and actually have like a complete representation of that. Maybe as a soup of all those elements, so we don't know like the interconnections and such, but at least have all vertices relating to all edges. Oh, I guess that would make it connected, right? So like an edge would mention two vertices, which might not be unique, right? So another edge might also mention the same vertex, and then that's pretty much it. I guess I could also link an edge to a tile, but we'll see if that makes sense. So I want to have like level mesh, or just mesh edge. I don't even know if that should be in the header, but fuck it. Mesh edge and mesh vert. And then here we can have mesh vert pointer verts, and we store 2 pointers, 2 verts. And then a vert will just be 2 a vector 2 p, and then we can have mesh vert verts, which is going to be the actual storage first verts, and we can have vert count, and then mesh edges edge count. Right? And we will allocate that stuff onto this arena. I guess the only question is how to organize all that in the arena, since they're supposed to be contiguous. There's probably more efficient ways of storing this, but I don't really care. So I save it here. So we generate level. Let's do a function preprocess level. And that's it. Oh, I wanted to use it. So I call it here. And okay, so what do we need to do? I need to go to all my tiles in the level. How are they specified? So we have tile flags, that's what I need. Do I need to go through width and height? I think yes, because I want to know the spatial representation of those tiles. Yeah, I want to know like upper neighbor and neighbor to the left. So let's say we're gonna have int y equals to 0, y is less than level height, y plus plus, x is less than level width, x plus plus, and then we only care about tiles that are opaque. Is tile opaque? level X and Y. I don't think I have that implemented, but I do think I set the opaque flag. Yeah, right here. So let's just do the same thing. Insert, do that, and then check for tile opaque flag. So if tile is opaque, we need to check it. Now, I don't think I want the outer edge. So I think I can literally skip the first tiles, or skip the whole apron. Skip the whole apron. And basically, for every tile, I want to check its neighbors. I want to check its so if I check its left neighbor, and it's open, then I need to create a new edge. So I'm missing one more thing here, I think, and that's associating my edges with the tiles. But okay, I thought through this again, and basically we're going left to right and top down, right? So what that means is that the tiles to the left of the current one we've already looked through, so we don't need to look at that. And also the tile on the top we looked at. So what we need to look at is the neighbor to the right and the neighbor to the bottom of the current tile. And if the neighbor to the right is open, then we create a new edge. Or rather, we say that this tile has an edge. But whether we create a new edge is we're looking to the tile to the top. If a tile to the top has the right edge, then we also associate this tile with that same edge. And we expand the edge to start at that tile and end at this tile. Right? So what's missing here is a link between tiles and edges. We do need it, actually. And again, I'm just gonna like completely splurge here and, you know, not care about memory whatsoever. I'm literally gonna have 4 edges here. I'm just gonna have like mesh edge pointer edges, and I'm gonna have up to 4 pointers, and that's gonna determine whether a tile is you know, if a border of a tile is associated with an edge, right? So then here we also need mesh tile, tiles, and int tile count. Okay. So I think my tiles will actually be spatially laid out, not sparsely. So I will have a mesh tile struct, which is 4 pointers for every tile. Because alternative would be just scanning through the list of tiles. Yeah. Let's just keep it spatial. So what we want to do here is generate a mesh, right? Let's just zero it out and then say mesh.tiles will be memory arena push array on the level arena. So push on the level arena, level W times level H worth of mesh tile structs and 0. And to be honest, this might be a lot. So pointer is 8 bytes. There's 4 of them, so that's 32 bytes. And this is 10,000, so that's 320K. $320K for this. But I'm just wondering what to do about edges. I'm still kind of toying with pushing the arena stuff a bit further. So in this case, I'm thinking like it could actually be a useful thing to have an arena for each of these lists. But I mean, it doesn't really make a difference though, because we still need to keep track of the count, and arena still has to be kind of fixed size. So I have to set an upper bound on it anyways. But yeah, I think it's fine. Let's just set an upper bound. Like, it can be pretty high. I guess that's the only thing, is that there I could just bind it with a nice size, but here I have to bind it with like the count of vertices, which is kind of like, you know, I don't know what's reasonable. And I also want to think about this idea of kind of keeping this data for longer. Like, ultimately, all I really need, I think, is edges, but the whole level mesh could come useful at some point. So it's like, why get rid of it? And even some of the intermediate steps, all that stuff could come useful, if for nothing else, then at least for debugging. So I'm down to kind of like start using memory like crazy and just like keep a lot of data saved in a kind of more wasteful way for like longer. But anyways, so let's push a bunch of vertices, which is 2 floats, so that's 8 bytes. I don't know, I guess I guess I can just do like 16K of those. What is that? 1496 times 4. 360. 384, is it? Yes, okay. So let's just do 16,384 verts. Mesh vert. And then let's say the same for edges. And edges is 2 pointers. So that is going to be 16 bytes. So in total, for example, this will be 32 bytes times 10,000 plus 16,384 times 8 plus 16,384 times 16. So that's 700K for this. Okay, whatever. Just interesting. Just curious. Okay, so then so yeah, I just skip my tiles. I don't actually need to save anything in that tile array. By default, it'll just point to nulls here, right? Which is fine by me. And then if it's opaque, then we possibly care about that tile. So if it's opaque, then I need to check the tile to the right. And I need to check if that one is not opaque. Now I wonder if I should have some kind of helper to get a neighbor tile easily. Or no, actually no. So let's check if another tile is opaque, the tile that is my right neighbor, right? So x plus 1. So I say if that tile is not opaque, meaning it's transparent, I need to build an edge there. But there are 2 options based on whether the tile above, so mesh the tiles at xy to I dx level w xy minus 1. If the tile above has an edge that is, so let's say that edge 0 is the north, then comes east, south, west. So in this case we're caring about the east, right? So the one to the right. So if the tile above has a neighbor, or has an edge to the right, so if that is pointing to anything, then I need to take that edge and expand it, right? So first of all, I need to say mesh tiles myself, basically. Right, my own eastern edge is gonna be mesh, oh, sorry, that's already existing, right? So it will be equal to that. So let's see, mesh edge pointer existing edge. So if existing edge, then we set our own edge as being equal to the existing edge. And also the existing edge, we want to expand. So it's going to be like from top to bottom. So we keep the start of the edge, which we're presuming is already set. And we're extending the bottom of the edge. So existing edge verts 1 will be the bottom of the tile that I'm on. And so if it's a tile number 0, then my bottom is going to be 0 plus 1 times tile height, tile pixel height. Wait, is this in pixels? Is this going to be in pixels? I think. Actually no. Because if I change while the game is running, if I change my tile set or something like that, there is no reason to kind of bake that pixel information in. At least I think. So let's say it's not going to be in pixel size. So it's basically going to be, again, if I am row 0, then my bottom is going to be at 1.0f. Or is it minus, sorry, is it going to be 0.5? How did I do that? When I render my level, I offset by minus 0.5f. But I think I offset because I want 0, 0 position to be at the start of that, like 0, 0 position when I render, I think. So yeah, I'm pretty sure that's how I have it everywhere. Can I double check that? Actually, no. 0, 0 is in the middle. Right? So this is the middle horizontally, right? So where I clicked on X is 7596. So actually the middle is 0, huh? Really? I was kind of thinking the whole time that it's not. So maybe I have something wrong in my pathfinding too. Because I'm pretty sure it mattered somewhere. I think I was just confused when I did this before, because I think it is more useful to start a tile at 0 and end the tile at 1. right? So 0.5 is in the middle of the tile. But already, like here, for example, when I calculate tile P just for this trace log, I round my float, which means that 0, 0 is going to be the center because, you know, from minus 0.5 to 0.5, we will round to 0, right? Or at least, you know, if it's relative, like to some other value, like 4.5 to 5.5, we'll round that to 5, right? And here I just want to truncate. So if I do this, here, then that trace log will be correct. And when I right click, I just order to move to that pixel position, world pixel position, divide by pixel width and pixel height, which is going to put us in the tile world position. And if the width is 32 and this is 32, then 32 over 32 should give us 1. Right? Which means we clicked at the end of one tile, at the end of tile 0, or at the beginning of tile number 1. Right? And then if it's 64, it will become 2. So 1 to 2 is between pixel 32 and 64. Which makes sense. So this will be correct. And in pathfinding, I'll just take a look at that really quickly. What is it called? Navigation. I round. Okay, I don't want to round. I also want to truncate. I don't know what got into me that I decided to round. So that should just truncate. So that means anything for like tile number 32, everything from 32 to 33 becomes 32. And then when I reconstruct my path, I do the opposite move basically. So XY, hold on. So no, actually I was thinking about so actually here, if I simply, so I guess that becomes the annoying part, is that to convert from tile space to the float space, I actually, or yeah, from like integer tile space to float tile space, like here, for example, we're reconstructing the path, which means that that is where the entity is gonna like come to, right? When it reaches the target. Which, if we're treating this as this kind of, as these nodes in the path in A star, that should be the middle of the tile. So in this case, we actually want to add to this 0.5 here when we construct our result path, because right now, like if I do pathing, yeah, you see how it goes to here. Like it should go to the middle of this tile or wherever this middle is, but it goes to the top. So yeah, that immediately is going to be the problem, so that should fix it. And then here we just set it to 2f, which is this and f anyways, so that's already as desired. And then I already removed the part that offsets when drawing the tile map. So let's see this. Yeah, like that looks right? It's moving in the middle of the tiles. And also, the other thing is, okay, so that's the middle. Why is it the middle though? Player entity, I set to player pos X and Y. Because I convert this already to floats. So this will be just like 0, 0 of the room, and then width already gets converted to float before we multiply. So this will be like in the middle of a tile. Or, oh, so it not necessarily, right? Like if it's an even size room, I think this is an example of that. Yeah. So I clicked and our vertical is at 40. Our horizontal is at 4850. So horizontally we are in the middle of a tile, but vertically we are right at the edge between this tile and this tile. So, I think it's fine. I don't really care. It makes sense, right? We're right in the middle of the room. Okay, so back to this now. We are working in tile space, so the edge of the vertex gets extended to y plus 1. And all of that converted to float. Right? Because if I am on tile 5, that means the beginning of the tile is 5.0, the end is 6.0. So to get to the point where the end is, I do 6. I do y plus 1. So the vertex of the end vertex of that existing edge, its y coordinate gets adjusted to be this. Okay, and then let's say we don't have an existing edge. Then I actually want to create a new edge. So I need to say mesh tiles at this location, and I think also it's also going to be eastern tile edge. should be something. So I need to get an edge. So this will be new edge. That will be mesh edges, mesh edge count plus plus. We want a pointer, right? So then we can point to the tile on that edge. Wait, what did I just do? But then we need to actually define that edge. Now our edge is 2 pointers to vertices. So new edge verts 0 needs to be something. And of course, new edge verts 1. And both of those should come from our main storage on the mesh. So that's going to be mesh verts plus mesh vert count plus plus. Yeah, so that's an array of pointers. Yep. Okay, so this dereferenced will still be a pointer. So I guess one thing is that even though we're referencing vertices like that, they're actually still going to be duplicated. No edge is going to share a vertex. But I think that makes sense because we don't know until we finish preprocessing. Maybe then we can deduplicate. Yeah, until the end we don't know. Because even if a vertex matches some other vertex, it might get updated by further consideration of the tiles. Okay. So this is a pointer, verts 0. This is a pointer. So I can just do this. So I just block copy the whole v2 into that place in memory. And what that v2 is on X it's going to be the same for both vertices, and it's going to be the beginning. No, it's going to be the end of the current tile on X. The right edge of the tile. And for Y, we will have the beginning of this tile. And then the other vertex will be same X, and then for Y we do Y plus 1. Right? And then we assign that pointer to be in the right edge of this tile. Oh, okay, so the other thing actually also is that, oh no, never mind. I don't care about the open tiles, so I don't need to do the other side of the edge. I don't need to assign this edge to the open tile. Although the way this is laid out does suggest that it should happen, but I don't think it needs to. Okay, so we do this for every opaque tile. We check if its right neighbor is not opaque. Okay, and then regardless if it was opaque or it was not opaque, we also check if its bottom neighbor is not opaque. And here we basically do the same thing. And I'm just gonna duplicate this. So here it's basically the same. So we're looking at the one to my bottom. So I need to see if my left neighbor already has an existing edge. So let's do x minus 1 here, and y being the same as the current tiles. And let's look at its south neighbor. So that's 2. And if my left neighbor, sorry, not south neighbor, but south edge. If my left neighbor, or if my western neighbor has a south edge, a southern edge, then my own southern edge becomes an extension of that edge. So I do this, and then I change x on that. X on the end of that edge is gonna be current x plus 1. And then if there isn't an existing edge, then we need to create a new one. And this one will be yeah, and then here it will be from x to x plus 1 on constant y. Right? No, on constant y plus 1. Okay, and then we set that to be the southern edge of the current node. Okay. Something like that. I'm not going to worry about not duplicating code here. I just want to see if anything works. So let's go here. We're including level. Let's call preprocess level. Let's try to build. Oh, I guess one other thing I'm missing is saving the mesh to the level mesh equals to mesh. So just copy that in there. All right, what's the problem? Mesh tab does not define this operator. Oh, right. So tiles, and then that is not a pointer, that's going to be dereference. So we do dot edges, right? Because this will dereference from an offset pointer from this. So then we do dot and we get the edges like that. Verts 1, that's gonna be P dot Y. Oops. Oh, the verts. Is not just a v2. So I need to do that. Yeah, I think that makes more sense. Yep. Fat fingering. Okay. So now let's just make a breakpoint right here and just cross the fingers. And the crossing of fingers was not successful. Oh wait, no, we haven't actually copied. This is what we're looking at. Okay, so that's something. I mean, looks good. Looks legit, right? I don't see any issue. So let's just draw something. Let's say draw level mesh debug API func void takes level pointer. And let's say that I just want to go through my edges. I is less than level mesh dot edge count. I plus plus level mesh edges I v2 start equals to that dot verts dot 0 or 0 dot p, no, arrow verts 0 arrow p, and then end is going to be verts 1, and then d draw line start end south color yellow, and d draw point start south color orange and end. Is it really that simple? Ah, no, it's not. We have to actually multiply it by level tile pixel width and level tile. Oh, no, that's not what I'm thinking it is. Okay, again, let's just debug. So, oops, I can just say that my width and height are equal. Okay, and then call that inside. Okay, so that actually, weirdly enough, I guess it can happen here. Draw level mesh debug pointer to game state level. Okay. What do we have? Mesh edge really? Edges zero. Oh, okay. Yeah, that will be the thing itself, but for verts, those will be pointers. Yeah. How did I store that? Okay, it's in here. Emacs. So that's going to be level tile map dot dot. What the hell did I call that? level tile map. Genius name. Level tile map. Forgot to do that. Whoa, interesting. Oh, so we do actually need to do the left stuff. But it's kind of cool though. So far it works. Kind of makes it annoying because I have to do something. Yeah, so there's like 4 options then, each of which could have 2. Or alternatively, I could process my transparent tiles, but I think that might be more difficult because I treat a lack of a... Well, actually, the whole mesh tile is laid out in there. I could do like if this and this, or not this and yes this. And then the same here. Let me just kind of blindly do this. Let's see if it just magically works. So basically this and this. Or not this and this. Or that for y. All right, so that's something. Let me just change some defaults. Although I kind of like it thick like that for debugging. But I think still reduce the point to like 8 and reduce the line to like 6. Oh yeah. Yeah, so that works. I think I have to definitely debug this more in depth, like just walk through it at least a little bit. And there are other things, like for example, already what I don't like is that all of this is spread out through this arena. So if I want to preserve this so that I can always like enable this, for example, for debugging this view that I had just now, at any point in the game, if I want to just enable it, I want to store it. And then obviously I don't want to just like use up the arena like that, where it's like just 700k and then most of it is empty space, right? But at the same time, I don't want to deal with having run out of this buffer that I assigned for this stuff. So I want like a good way to pack it, but I don't want to do like the brute force thing. I wonder if there's something smart kind of design-wise that can be done here. Like for example, having 3 separate arenas, as I was saying before, and then like all of the verts for like, let's say, different levels or different iterations of a level, maybe I could have in the same arena. Or, you know, in the same... I guess that doesn't exactly make sense because this is per level, and each level I'm thinking will have its own arena. And if that's the case, then there will only be one of this. So I could have multiple arenas. But what sense would that make? Because in the end of the day, like, it doesn't really help me. In the end of the day, like, I will still have that wasted space. I guess it can be packed. I guess it can be packed. Yeah. Okay. I think that's it for today. I'm honestly pretty happy to see that something. I thought that I wouldn't get to this point today, but okay, that's great. All right, so then that's the end. Goodbye.